Let's do a couple more examples of function composition. So in this case, you're given a table rather than a function. So a function doesn't have to be represented as an equation. It could be a table or a graph. As long as you're given inputs and outputs, you're good to go. So in this case, they already wrote this one out. Instead of putting like the little O, they put g of h of -3. That's fine, that actually helps us. Remember, start on the inside, and we're going to do h of -3 first and go from there. So let's do h of -3. That means find your function h. Here it is, it's this table, and see what happens when the input is -3. So the input is the x row, and so that happens right here. When the input is -3, the output is 2. So h of -3 is just 2. Now I'm doing g of 2. So again, we'll go find the g function, which is this table, and find the input of 2, which happens here. The output is 7. That's my final answer. Let's try another one. So h of 0 means we're gonna find the h function and go where the input is 0. So here's the h function. This is an input of 0. The output is -10. So this evaluates to -10. So now I'm doing g of -10. So go find the g function, go to where the input is -10, and see what the output is, -17. There we go. I like tables. You don't have to do that much work. You just go look up the numbers. All right, let's take a look at a graph. This is the same graph from the last lesson on functions. We've got a function f here, which is this blue one, and g is this red function. And I want to find f of g of -2. Remember, this is not multiplying, it's a little o. Usually they're smaller than that, sorry for my typing. I'm finding f of g of -2. So start on the inside and find your g function and go see what g of -2 is. So my g function is this graph, and the input of -2 happens where x is -2, and the output there is a 2, because this is the point, -2, 2. So when the input is -2, the output is 2. Now I'll find f of 2. So go find where the x value is 2 and see where f is at. This blue one is f. It's currently at 0, so my output is 0. That's my final answer on that one. Finally, this is a little weird. It's g of 1, and that's okay. That means I'm going to find, let's start on the inside and find the g function, which was the red one, and find the output where the input is 1. So when the input was 1, the output is -1, because this is the point 1, -1. Sorry, my ones are bad. So when the input was 1, the output was -1. Now we're actually going to use the same g function, but now my input is a -1. So go to the g graph again, but this time find an x value of -1, and let's see where the graph is. It's up at 3, so my new output is 3. And that is how you compose functions. Oh, there's one more example, sorry. I got excited. I wanted to show you a few more slightly more complicated ones. This is g of f of x cubed. So g of f of x cubed. meaning I'm going to take x cubed and put it into f. So here's f. Let's actually write this out as like input squared plus 2 times the input plus 4. But instead of those x's, I'm putting in x cubed instead. All right, and then let's simplify just a little bit. X cubed squared means I have x cubed times x cubed, which is going to give me 6 of them, or 3 times 2 is 6. 2x cubed, and then plus 4. So that was all the work for this inner function. Now I'm going to take this and put it in place of that. So now I'm going to do g of this whole thing. We can do this. So go find the g function. Here it is. It's just 7 times the input. Not too crazy. 7 times the input. And this is my input. I know it's very long, but that's okay. All right, now just distribute the 7 and we're good to go. 7x to the 6th. 7 times 2 is 14. 7 times 4 is 28. And there we go. Last one, and I'm gonna clear this out. Look, I like when it spells words. I'm sure you guys will be pronouncing these as gog and goff and all this stuff, but this is g of x of x, g of g of x plus 1, or g composed with g. So this is basically g of x plus 1. So start on the inside. The g function is just 7 times the input, but I'm going to take out the placeholder x and put in x plus 1 instead. So that is 7x plus 7. Okay, this is going to replace that. So now I'm doing another g of this new input, 7x plus 7. So go find your g function, which is 7 times the input. But now my new input is this. So that's 49x plus 49. And fun fact, you can actually keep going. Like I could have g of x. I would just take this and put it into this and put it into this. So if you want to just go crazy, you can. All right, that's the end of that one.